Okay, so we're live right now, recording. There's a little, if you're in Google Plus and you watch these videos, it might actually say this is starting now, and somebody could be watching this video as it's going. So they can hear me talk right now. Okay. This is what you'd be seeing on the video. Right here, you'd be hearing me talk. So we're going to study scientific notation. Again, I've talked about a lot about engine tolerances with you. You've kind of read the article. They just kind of give you an idea. There are lots of ways that an automotive manual might present a number to you. There's a lot of these things. And do you guys know how big some of these measurements are? Okay, 0.0, let me give you an idea of how big these are. That, if you look at the bottom of your assignment, is oil film thickness on the main bearing. Okay, that's 1/100th of your hair. Okay. So when we say these things, we're talking about very, very small measurements. Okay. Which is why we need different ways to talk about them. Okay. So one way is for just what we call decimal notation. And that would be something like that. Okay. Please write this down. It shows you're being responsible. And then I know you have it to take with you. Yes, I know it's going to be on the internet. I do, but that physical writing it down helps you remember it better. We can also write that. Okay, a lot of times auto manuals are probably going to be in this form. Right. We can also write it verbally. Does anybody remember how to say that verbally? Do you remember your place values at all? Tens, hundreds, thousands, 10,000s. So this would be 10. So that would be like 1/10. 100. We have 1,000. And then this one is the next one, if there was one here, would be 100,000. That's all I'm going to go for. We don't have to go any farther for your sake. You can go into millions next. So millions, 10 millions, 100 millions. Then you go billions, 10 billions, 100 billions. It starts to form a pattern. Okay, but for your sake, this is all the farther I'm going to require. Okay. So this is 1/10,000th. You know how to write that as a fraction? One over 10,000. Yeah. You know how to say it, you can write it very easily. Well, we can write scientific notation. And this one, for some reason, confuses people. Honestly, I didn't have it down until I was in college, and I was a math guy. Okay. So, that's scientific notation for that. So, what have I done here? Yeah, I moved the decimal 4 places, right? So this needs to be a single digit. Maybe right on through play. Okay. And this means I moved the decimal 4 right. That never worked for me. You know how I remember if it's positive or negative?
You know which positive or negative?
No. Is that a small number? Really small number, right? 10001. That's a negative. That's how I remember it. Okay. So this is a really small number. That means that's going to be negative. And if it's a really big number, that will be positive. So I don't worry about move left, move right. I just never could do this straight. If you can, great. But it doesn't work. So, let's look at a big number. Like, hopefully if you're an auto mechanic, you make that much money here, right? I can tell you for a fact my dad does not. He's been doing it for almost 30 years. No longer than that. He was your age. He got a job at a Chevy garage right out of high school at 18. So now he's 55. He just turned 55. So yeah, so 37 years in a mechanic, and he's still, he'll never make that much. Neither will I, honestly. So this is what verbally? 2,500,000 works. 2.5 million works. 2.5 million works. And lots of ways to write that one down. So. Do you want me to label the spots here? Or are you okay with those? Most people are. The decimals are good. Okay, so 2,500,000. Let's, okay, the fraction, there's not really a whole lot we can do with this. This is not going to really come into play. Okay. That's more for the smaller numbers. Okay, let's scientific notation here. I need 2.5. Make that a single digit, right? The way I do it, how many decimal places? Positive 6 is a really big number. That's how I do it. Or you could say move left 6. That's fine. But I just say big number, positive exponent. Okay. And you don't need any more than one spot here. Don't worry about more than one decimal place here. Just have it as is. Sometimes I'll run it out 2 or 3, but no big deal. Well, let's try one more. A little bit different. 0.00037. You know how to say that? Good spot. Close. Okay, 37. Right. And what place is that? In that place. Yeah. You go with the last place value. That's the one you use. You guys in the back see that low? You're okay. Turning around. So use the last place value to say the number with the place value. Okay. Or, oh wait, hold on. That's not it. No, it's not. Yeah, try to mess up correctly, please. Which one is it? Yep, you got it. Good catch. Should be 100. Tens, hundreds, thousands. Now it's better. How would I write that as a fraction? Over 100,000 now. We can't reduce that fraction to 37 to the prime number. And then scientific notation. Somebody else out there. Maybe what? I just. Yeah. 1, 2, 3, 4. Oh, hey, that was wrong too. No, it's not. It's right. The kicker here is that this is 37, so kind of goes with it. Just count your decimal spots. I give you your negative number. Okay. Anything else? You think you can handle that? All right. So you can go. We got about 15 minutes. This sheet, if you don't finish it in class, it'll be your homework. I did, just FYI, I put some different things on there, like you have stock engine application, performance, drag. The NASCAR row is blank. If you can find that information and want to do the work, I'll give you some extra credit there. And then there's some varying manufacturing tolerances, main bore alignment tolerances. Okay, just only a few different ways decimals are used in cars, but there are tons. But just a few. We get the video shut down.